So we're going to skip over example 2 and start with example 3. So it says the height of a batted baseball as a function of time is given as h is equal to negative 6t squared plus 6t plus 13, where t represents the number of seconds that have passed since the ball was hit, and h represents the height of the ball above the ground in meters. So again, we have a new scenario. The first thing you always want to do is define your variables so that you know what you're working with. We have our independent, or our x variable. From our equation, we see that x has been replaced with t again, so that represents time. It's represented as t, and again, specify the units, so in seconds. And then we have our dependent, which is y, and in this case, again, it's h, the height above the ground in meters. So height above ground, and that's represented with an h, and in meters. So this is very similar. Okay, so again, we have two equations, one in standard, one in vertex form. If you take a look at this, this is very similar to the image that we saw earlier. In the previous image, we had a cannon here. The cannon was shot, and then we followed the trajectory or the pathway of the cannon. Here, it's the exact same situation, but we have a baseball instead. So here, again, let's first look at our axes. Our x-axis here represents time, t. So again, time can't be negative, so must start here at 0. Our y-axis represents height above ground, and that's h. And again, the height will start at 0, because if you have a height of 0 above the ground, you're on the ground, or the baseball is above the ground. So in this case, again, at time is equal to 0, this is where the baseball was at. Someone hit the baseball, and then it followed a parabolic pathway as it came and eventually hit the ground down here. So again, they've provided you with an image here, but you should be able to solve all these questions without the image using just these equations. So let's go to the equation, the questions. So A, use the graph to determine how high the ball is just before it is hit. What is the value of t at this moment? Explain how you can use the equation to solve this question. So again, whenever we're solving these problems, we want to write down what has been given to us and what is required. So here it says, use the graph to determine how high the ball is. So we know that we need to find our height. That's what's required. But they didn't really give us a time. It just said, use the graph to determine how high the ball is just before it is hit. They didn't give us a specific time, but you should be able to use this wording to think of what time they are talking about. Right, so remember, if you take a look at the units again, it says the number of seconds is represented by time that have passed since the ball was hit. So if the ball is about to get hit, that essentially represents time is equal to 0. So time is equal to 0 is just before the ball is hit, and as soon as it's hit, then we follow what the ball does over a couple of seconds. Okay, so even though they didn't explicitly give us a time here, based on the context, we were able to determine that time. So if time is 0, what is height? Well, let's go to our graph. Time is along the x-axis, time is 0 here. The height is 13 meters. So we know that our height should be 13 meters. How can you find this exact answer using the equation instead? Well, let's do that. Let's write out the equation. Again, they've given us two equations. We'll just randomly choose one. So I'm going to choose the standard form in this case. Okay, and here again, the time that they gave us was 0 because it was just before, again, the ball was hit, which is at 0 seconds. So we can plug in 0 for our time. So 0 squared times -6 is just 0 plus 13, which equals 13. Again, don't forget to write the units. And at the same time, don't forget to write a sentence. So the ball was 13 meters high before it was hit. Okay? Something to keep in mind here. Any one of these equations, either the standard or vertex form, would have given us 13 meters. But there was a specific reason why I chose the standard form. When time is 0, the height is a value. This point occurs on the y-axis. So this is the y-intercept in this case. And remember, with standard form, it's easy to read the intercepts because these two terms will essentially be canceled out because we're plugging in zeros as time. Okay, so just some things, some connections you should make from the previous unit. Let's look at the next question. Use the graph to determine the highest point the ball reached. At what time was this maximum height reached? Explain how you can use the equation to solve this question. So in this case, we want to figure out the highest point, which is height, but we also want to figure out the time. So we need to figure out both variables. But the biggest here is the fact that they said something along the lines of highest point. To determine the highest point or highest height, which obviously doesn't, biggest height, the highest height that the greatest height probably sounds better. The greatest height that the ball has reached. So whenever you see words like highest or lowest, you should think of words like max or min. So highest would mean a max value. So let's take a look at our graph here. So we can see that it reaches the max value around this range, but it's really hard to exactly say what time that is, or exactly say what height that is, or exactly say what time that is. So because the graph doesn't provide us with nice, neat numbers, let's choose one of the equations to work with. Because we want a max value, we know we want the vertex. So let's take a look here. We have standard form and vertex form. We're going to go with vertex form because we can read the vertex directly off of it. So I'm going to copy down the vertex form. H is equal to -6 t minus half squared plus 14 and a half. That is my vertex form for this particular scenario. We know that the max and mins are determined by the vertex. So let's write out the vertex here. So the vertex for this will be, again, I take the opposite of this. This is -half, so I'm going to take +half, and then I just copy this down. Remember, though, this vertex now has a context behind it. So if I take a look at the x variable, the x in quotations, remember, we're no longer dealing with an x, we're dealing with time in seconds. So what that tells me is my vertex actually represents 1/2 seconds. And the y variable here, again, it's no longer represents a generic y, it represents the height in above the ground in meters. So it's 14.5 meters. So again, we're putting the context. This half represents time, this represents height. So what this tells me is my vertex is telling me that at half a second after the ball was hit, the ball reaches this maximum height of 14.5 meters because this is the vertex. So the sentence we can write here is the maximum height is 14.5 meters, which was reached at half a second. So if I take a look at my image, that kind of matches up. Here we can say this is about halfway between 1 and 2, and this is halfway between 4 and 5. So the vertex here does tell us what the max and min value is. So again, just to reiterate, if they say something like highest or greatest or biggest, you know that you're going for max. If they said something like lowest or smallest or least, you're trying to find a min. But regardless of whether you're trying to find a max or a min, you need to find the vertex. So we found the vertex here. Then we looked at the context behind the vertex. This represents time, so seconds. This represents height, so meters. So what this tells me is the highest point on my graph, because this is a max, is 14.5 meters, and that occurs at half a second. Again, let's say we didn't have a graph. The highest point, that vocabulary will tell you that you have a max, but you can look at your formula as well. You have a negative up front, which means your parabola is pointing down, so you know that that will have a max value. Let's move on to the third question. Use the graph to determine when the ball hits the ground. What is the value of h at this moment? Explain how you can use the equation to solve this question. So again, we have another question where we have to write out our givens and required. So given, required. Based on this question, it says use the graph to determine when the ball hits. So when represents time. So the required is we want some sort of time. So that's what we're trying to figure out. And in order to do that, we need to know a given. We need to know a given height. But again, in the question, they don't explicitly give us a number. It says use the graph to determine when the ball hits the ground. Well, let's go back to our graph. The y-axis represents height above the ground. If we're hitting the ground, that means we must be 0 meters above the ground, because 0 meters above the ground is the ground. So this here represents the ground, okay? So what we're essentially trying to figure out, well, what is the time when the height is 0? So let's go back here. We know our height is equal to 0. It says to use the graph to determine this. So let's go up here. When the height is 0, the time is somewhere there. Again, it's very hard to estimate what that time is. It's a little over 2 seconds. So let's say it's about that would be 2.5, so 2.1, 2, 3, 4. It's about 2.05 seconds. Again, right now we're just estimating. So I'm going to write about 2.05 seconds. Obviously, if we're just asked to estimate, that's a pretty good estimate. But if we want the exact time when the ball hits the ground, we're going to have to use an equation. So let's write out the equation. Whenever you are given a question where you're given the y variable, it's best to use standard form. So let's look at standard form. H is equal to negative 6t squared plus 6t plus 13. I'm going to put 0 for my height because that's what I've been given. It's hitting the ground, is equal to negative 6t squared plus 6t plus 13. Why did I tell you to use standard form here? Because when your height is substituted for a particular number, you now have a quadratic equation that you need to solve. And so you need that in factored form. So it's easier to go from standard to factored form, or from standard form to the quadratic formula. So we have this equation. Again, we should try factoring it, but I'm going to save you some time. I'm going to tell you this does not factor. So the only other way to solve the quadratic formula is by using, the quadratic equation is by using the quadratic formula. So let's list our A, our B, and our C. Our A here is negative 6, our B here is positive 6, and our C here is 13. So far, I've been telling you to make sure that the A is positive. So if you want to move all of this to the other side, that's totally fine. I just want to show you here that even if you keep it negative, you'll still be able to get the right answer. So let's write our quadratic formula. Normally, we'd write x is equal to negative b and write out the entire formula. I'm going to vary it slightly here. I'm going to write t is equal to negative b plus minus root b squared minus 4ac divided by 2a. Why? Because I'm no longer solving for x's, I'm solving for t's. Once you have the equation, you can plug everything in. Don't forget your brackets. So that's just negative 6 plus minus root 6 squared minus 4, negative 6 times 13 over 2 times negative 6. Again, we want to now clean this up. I said to always start with the section underneath the square root. I'm running out of space here, so let me pull up a piece of paper that I can write on. Just give me 2 seconds. Okay, so I'm going to do the section underneath the square root first. So we have 6 squared minus 4 negative 6 times 13. So 6 squared is just 36. Again, these are larger numbers. For this unit only, I'm going to let you use your calculator. So negative 4 times negative 6 times 13 is equal to 312. 312 plus 36 is equal to 348. So if I was to simplify this, I have negative times 6, so negative 6 plus minus the square root of 348 divided by negative 12. Again, t equals that expression. Again, I'm running out of space here, so I'm going to do the rest up here. So I'm just going to copy this down. T is equal to negative 6 plus minus root 348 divided by negative 12. Remember, this means I have 2 possible t values. So I have t1, where I take the positive version of the root 348, so negative 6 plus root 348 divided by negative 12. And then the second option, where I take the negative root 348, so negative 6 negative root 348 divided by negative 12. Again, you just need to plug these into your calculators, keeping in mind that you should plug them in by putting brackets around the top and the bottom. Okay, so let me just do this quickly on my calculator. So again, to show you, you want to put brackets, negative 6 plus root 348. Let me see if I can increase the brightness a bit. No, I cannot. Divided by negative 12, which gives me negative 1.05. Again, we're going to round, so I'm going to put the about sign, the wavy sign, and then the next half, negative 6 negative root 348 divided by negative 12, which is T2 is approximately 2.05. Okay, again, don't forget the context behind these. T was measuring time. This is in seconds. Already, you should see that one of these solutions are meaningless. Again, we cannot have negative time. So this does not work, and this is our only answer, 2.05 seconds, which happens to match up with what we initially predicted as well. So once you do that, don't forget to write out your little sentence. So the ball hits the ground. And here I'm going to word it so that I say something like at about 2.05 seconds. I wrote the at about because, again, that's an estimate. That's a rounded answer. It's not exactly at 2.05 seconds. Okay. Next, I want you to actually try this on your own. Again, I'll read the question to you, try it on your own. So pause the video, try it, and then when you come back, I'll have the answer there for you. So use the graph to determine when the ball is 12 meters high. Explain how you can use the equation to solve this question. So I do want you to use the equation to solve this question. Again, try it on your own, and then we'll take it out. If you need more space, do grab another piece of paper. Okay, so this is the answer. Again, I'm just going to quickly go through what we did. In the question, they said the height is 12 meters, so that was the given. They wanted us to figure out when or the time. So again, I've replaced my h with 12, again, using the standard form because I was replacing my y or dependent variable. And then I brought the 12 to one side to make a quadratic equation in the proper form. I tried to factor this, it didn't work, so I wrote out my a, my b, and my c. I plugged that in. They gave me 2 scenarios, one where time was negative 0.145 seconds, The other where time was 1.145 seconds. Again, this contextually didn't make sense. So the ball is 12 meters above the ground at approximately 1.145 seconds, which is also what I see from this graph. So 12 meters is around here, and that looks like it's about 1.145 seconds, like the equation told us. So hope these examples were helpful. What I want you to do for homework is you're going to do these two questions. So the next lesson, you're going to do these questions on your own. You're going to hand them in, and you're not going to do all of these questions for homework. I've reduced it so that you just have to do page 223, number 6A and 8, page 226, number 9, and page 142, number 14. So I need these two questions done, example 1 and 2, and handed in, and then you're going to do this homework for extra practice. Thank you.